In this video, the objective is to set up and solve a proportion to find missing side lengths in two similar polygons. Now there are multiple proportions you can make within a set of polygons, and I'm going to show you both ways. Either one's going to be fine. It's personal preference as to which one you would like to use to solve for missing side lengths. In this first example here, you have a couple of rectangles, it looks like, and they give you 3 side lengths, and one is missing. In similar polygons, these side lengths are always proportional or have the same ratio. So therefore, we can set up an equation with 2 ratios equaling each other. So if I'm looking at the side length with the missing value x, that corresponds to the shorter side length in the second picture, or the second rectangle, 5. So I can write x over 5. You could write 5 over x, it wouldn't matter. The order of the first ratio won't matter, but the order of the second one does depend on what the first one's order is. So if you have x over 5 in this first ratio, that's big over small. And that same setup has to follow for the second ratio. So 72 and 12 correspond. 72 must go on top because that's part of the bigger rectangle. And 12 must go on the bottom because it's part of the smaller rectangle. Now, if you wrote it as 5 over x, obviously the second ratio would flip as well. It would be 12 over 72. You can also set up a different way. If you wanted to do side lengths that correspond in the same rectangle, for example, x and 72, the second way of doing it, x and 72, you could write it as x over 72 equal to, and then the second pair would be 5 and 12. Now you have x over 72, so you need to have the second ratio correspond. X corresponds with 5, so 5 is going to go on top and 12 on the bottom. These would have to correspond to each other. And those are your two options for proportions. Now, which one you choose won't matter. You'll get the same answer because they're both proportional. If I solve the first one, cross multiplying, x times 12 is 12x. 72 times 5 is going to be 5 times 70, which is 350, plus 5 times 2, which is 10. So that's 360 when you add them together. Divide both sides by 12, and x is going to be equal to 30. And that's how you go from having a picture of two similar polygons with a missing side length to a proportion to solving for the missing side length. Let's try another example. This one, number 4, has 2 missing side lengths. So if you have 2 missing side lengths, you need 2 proportions. Okay, so let's write that down. 2 missing side lengths. 2 missing sides, you need 2 proportions. So 1-to-1 correspondence. If you had 3 missing side lengths, you need 3 proportions, and so on. So let's look at solving for B first. B corresponds with 41.25. So that can be my first ratio. Now, since I'm missing a side length in the first ratio, I want my second ratio to have both known lengths. I can't put in a second variable here because then I couldn't solve for the first. So a known ratio would be these two side lengths, 16 and 80. They correspond. You know both of those numbers, so you can put them into a ratio. B is on top right now in the numerator. It's in the smaller figure. So therefore, 16 being in the smaller figure has to also go in the numerator. 80 is in the larger rectangle. It goes with the larger side length. So essentially, this is small over big. Now, cross multiplying, you're going to have 80 times B equals 16 times 41.25 is going to be 660. And last step, divide both sides by 80. 660 divided by 80 is going to be 8.25. So you have found one of your side lengths B. Now the second side length C, kind of drawn over it. I'll erase this circle so you can see it. C is right there. C is corresponding to 16. C over 16. And you can use the same ratios before with a 16 and an 80. But notice how I put the C value on top, the numerator. That's big over small. So it's actually going to be 80 over 16 now. Because I put big on top now instead of the small. Now look at this proportion. You have the denominators the same, 16 and 16. Therefore, C has to be 80. And if you actually do the math here, you'll have 16C equals 80 times 16. It's 1,280. If you divide both sides by 16 afterwards, you're going to get 80 again. In this example, they give you a perimeter of one of the triangles, and they ask you to find the missing side lengths of 3 sides. So you are missing 3 side lengths, or 3 sides, so you therefore need 3 proportions. So the perimeter of DEF is 252. So this big triangle here, the perimeter is 252 all the way around. They don't give you the perimeter for this one, but we can find it. You're simply just going to add up the 3 that you know. That gives you the perimeter all the way around the triangle. So 21 plus 24 is going to be 45. 45 plus 18 is going to be 63. Now you might be wondering, why is it important to know the perimeter between 2 triangles? Well, perimeter is made up of side lengths, and in similar polygons, side lengths are proportional. So therefore, perimeters are proportional as well, and you can actually stick those right into the proportion and find missing side lengths that way. So if I have the 2 perimeters, I can do 252 over 63 and use that in every single proportion that I have to set up to solve for missing side length. So let's say, for example, we're looking at n here. N is in the larger triangle. That goes with the larger number, 252 on top. On the bottom, n is df. df, right here, in this original statement, corresponds to AC. And AC is 21. So that's one of your proportions you'd set up to solve for n. For m, repeat the exact same perimeter ratio. M is in the larger triangle, so it's going to go with 252. M, ED, is the first 2 letters. AB is corresponding then, and AB is 18. That's the second of your proportions. Your third proportion, you're looking for O. You're going to have 252 over 63 again. And O is in the larger triangle. And O, EF, the last 2 letters, corresponds with BC, the last 2 letters. And BC is 24. So this is 1, 2, 3 proportions set up for you to solve for 3 side lengths. And notice how 252 over 63, the perimeter ratio, appears in all 3. You can reuse it as many times as you need.